Yeah, for today, we are looking for the rule of inferences. Before this, we have learned for the quantifier and also for the predicate. Okay, and then for today, we are looking for the rule of inferences. Inferences basically for the rule of inferences, also known as a logical form or a guide consisting of premises or hypotheses and draw some of conclusion. Before this, we have learned hypothesis and also conclusion. From the hypothesis implies the conclusion. And for today, we are looking into the uh, logical form, logical form or guided logical form, logical form. Okay, logical form or guide consisting of premises. Okay, this one consisting of premises, premise, premises. Okay. Okay, later we see what is premises. Uh, okay, and then for the output, later on we draw a conclusion. Okay, conclusion. Okay, for some definitions, we refer to a theorem is a valid logical assertion which can be proved using two main methods. First one is using axiom, that statement which are given to be true. Lah. Okay, and then the second one is by the rule of inferences that allows for the deduction conclusion from the premises or hypothesis. Lah. This one I have explained. Okay, and then valid argument. You can see this one valid logical assertion or valid argument is when a conclusion is true, whenever all beliefs are true, and invalid argument is called fallacy. Fallacy later we discuss later on. Fallacy as noted later in the discussion. Okay, and then we have several rule of inferences. Lah. Here we have nine rule of inferences. Later we discuss this one one by one. For example, we have a modus ponens, modus tollens, and then we have a hypothetical syllogism, and then the disjunctive syllogism, conjunction, okay, constructive dilemma, simplification, absorption, and so on. We have nine. Okay. So far, do you have any question? Is it okay? Okay. Okay. And then, if you take a look for this one, we have a logical assertion. Basically, for the logical assertion is you are using for the valid reasoning. For example, if the truth of the premise logically guarantee the truth of the conclusion. Okay, we are talking lots of the premises and also for the hypothesis. Okay, and then we have axiom. Axiom in a discrete manner is the word is come from origin Greek. That was or fit. Okay, fit when the command itself as evidence. And then we have axiom. We have a seven axiom. Okay, for example, you can have if equal are added to equal, if equal are subtracted from equal, things that coincide with one another. We have the whole is greater than a part. Okay, that statement or proposition, which is regarded or referred as being established, accepted, or self-evidently true. Okay, axiom you can call a proposition, call a proposition or statement. Okay, or statement which is regarded to be accepted. Okay, to be accepted. That you can have the evidence. You need to have the evidence to be true. Okay, and then we have two here, a pre-theorem, and then we have a post-theorem. Pre-theorem is, we call it as a lemma. Okay, and then the post-theorem we call a corollary. Corollary. Okay, they have two main, okay, two main definition here. Uh, for the axiom, you have a lemma. Okay, and then the other one is, we call it as a corollary. Okay, in mathematics, informal logics, and argument mapping, lemma, or we can call it as a plural lemma or lemmata, is generally minor proven proposition for the pre theorem, which is being used as stepping stone to a larger result. For example, we have a broken or breaking form of the same morphology or lemma. Okay, pre-theorem, which breaks the lemma by using index. Okay, this one is a pre-theorem. Pre-theorem. For example, if you have a true statement used in proving other statement to be true, okay, there is a less important theorem that is helpful in the proof or other result. Okay, and then proof. You need a proof to explain why is the statement is true or false. And then later on, you can see a conjuncture. Conjuncture believed to be true, but for which we have no proof. That one is conjuncture. That one is some of a fallacy or ambiguity in discrete math. Okay, do you have any question? Okay, whereby the corollary is a theorem connected by short proof to an existing theorem. And this one is the post theorem. The use of the theorem corollary, rather than proposition or theorem, is intrinsically subjective. It is depend on the situations. More formally, proposition B is a corollary of proposition A if B can be readily deduced from A or it self-evident from its proof. Okay, we have a term corollary. Okay, this one is very subjective. Okay, this one is pre, and then this one is post. Okay, we define after. Okay, and then we have a rule of inferences from the hypothesis. We use the conjunctive and conjunction from H1, hypothesis 1, hypothesis 2, hypothesis 3, until hypothesis n. Okay, and C we describe as a conclusion. Means that therefore or it follows that. Okay, conclusion for the hypothesis. Okay, here we have rule of inferences. The rule of inferences, later we see that we have 10. Rule of inferences. Okay, rule of inferences is mathematical logic. Mathematical logic used for the logical proof. Proof. Actually, what is the proof? Proof is valid argument that can be determined the truth value of the mathematical statement lah. Proof. Okay, we need to prove. Proof is a valid argument. Okay, valid argument that can determine the truth value. Okay, here we can have rule of inferences from addition. First one, secondly is simplification, conjunction, and modus ponens lah. Okay, I explain one by one. Syaril okay ke Syaril? Syaira? Oh, tengah call lah tu. Call siapa? Okay, rule of inferences for addition. For addition, for example, you have P as a hypothesis, it implies C is a conclusion. For the conclusion, okay, as we can see is P or Q lah. Okay, P or Q lah. Okay, it is basically is a disjunction introduction, or we can call it as addition. Okay, also called as introduction. You can also call addition or introduction. It's a rule of inferences of propositional logic and almost every other deduction system. Later we see simplification, we see conjunction, and so on. The rule make it possible to introduce the disjunction to logical proof. It is the inferences that if P is true, then P or Q must be true. Okay, that implies if P is true, then the conclusion P or Q, P or Q must be true lah. Okay, this one implies the truth value. Okay, so far ada question Akif boleh ke? Kalau tak faham bagi tahu sebab it is important to know and to understand from the beginning. For example, if you say that 1 plus 1 equal to 3, the premises, the false statement that we granted. Okay, and then we have another example. The premises P or negate P, and then we have by addition P and negate P or Q lah. And then we have tautology, and later on we form the disjunctive. Disjunctive. Okay, this one is we look over later lah. Okay, but for the addition, it's basically it's called introduction. Addition or introduction is a rule of inferences, basically in professional logic and almost every deduction system. The rule make it possible to introduce the disjunction. Disjunction. Okay, if you see for the first and second are the same. Okay, if you look the Condition 1 and condition 2 are the same. We have hypothesis and conclusion. Okay, this one implies. The bar one is implies. And then as a conclusion, you have a three dot. Okay, P or Q lah, as a conclusion. Uh, okay, this one we can call it as a conclusion or syllogism that generally used before the logical consequences, such as the conclusion of syllogism. The symbol consists of three dots placed in the upright triangle and read therefore. Okay, we need to read this one as a therefore. Yang tiga titik ni. Therefore, P or Q, okay, for the hypothesis implies implies P or Q. Therefore, as a conclusion, we read it as therefore lah. Boleh? Mazatul boleh ke Mai? Oh, tak buka ni lah kamu ni. Okay, and then number two, we have simplification. Simplification basically is when you look P and Q. Therefore, P lah. Okay, we can have also P and Q are also uh, Q lah. The process of making something simple or easier to understand. Okay, to understand. Basically in oh Syaril ni dekat mana tu kat rumah lah. Hmm. Okay. Okay, discrete math Uh, okay, we have a simplification. We want to simplify the inferences. Okay, for example, we have P and Q implies P, or we can have P and Q implies Q lah. Okay, okay, this one is you want to use simplification rules. Okay, for example, he study very hard. He is very the best in the boy in the class. Therefore, he study very hard. This one is a simplification example. Again, he study very hard as a P, and he is very best boy in the class. Very handsome or very best. Then, therefore, we can say that he studies very hard as a P. Boleh? Example for uh, addition. Let P be proposition. He studied very hard is true, and then therefore after he studied very hard, or he is a very bad student. Okay, we can see for the Q proposition, he is very a bad student. We have all therefore. Okay, and then we have a simplification. Uh, we can say that P and Q is a premises. Then we can have a conclusion, or we can use the simplification rule to derive P, to derive the P, or to derive the Q. For example, if we can say that he studied very hard and he is very best boy in the class, therefore he studies very hard. Okay, that one is simplification. Okay, number three is conjunction. Conjunction is P and Q. Okay, P and Q, as you can see, is hypothesis 1 and hypothesis 2. Okay, we can use conjunction rule to derive P and Q. Okay, for example, here we have hypothesis one P and okay, because you implies we need to use the conjunction, and H2 is Q lah. Okay, let be P. For example, let be P. He is very hard. He study very hard, and then let Q. He is the best boy in the class lah. And then for the conclusion, therefore he study very hard and he is very best boy in the class lah. Okay, conjunction. Okay, is it okay? This one is H1 based on the hypothesis. Hypothesis 1 and hypothesis 2 lah. Okay, and then the third one we have a modus ponens. If P and P implies Q are two premises, we can use modus ponens to derive Q as a conclusion. Okay, for example, here we have H1 and H2 implies Q, and therefore we can have Q lah. For example, if you have a password, then you can log on to the Facebook lah. Okay, let's say you have password P. Okay, therefore you can log on to the Facebook as a Q lah. Okay, you must have the modus ponens to derive the Q. Okay, this one, and then therefore you can log on to the Facebook. This one is modus ponens. Okay ke? Faham ke? Tak faham? Nanti later we see the example later on. Another example, modus ponens is a method by putting and placing by placing or implication, elimination, or affirming the antecedent. It is a deductive argument form and the rule of inferences. It can be summarized: P implies Q, P is true lah. For example, tadi yang kita as we can see, if you have the password as a P, then you can log on to the Facebook lah, Q. Okay, and then P, you have password and uh, log on to the Facebook lah. Okay, therefore you can log on to the Facebook lah. That one is modus ponens. Okay, and then we have modus tollens. Modus tollens. Modus tollens are two premises. We can use modus tollens to derive the negate, negate Q lah, negate negate P. Okay. Okay. For example, if you have a password, then you can log on to the Facebook as P implies Q. For the modus tollens, you cannot log into the Facebook lah. Therefore, you do not have a password lah. That one is modus tollens. You you derive two premises with the negate. Is actually it is a acronym for the modus ponens. This one is in the mode of denial. You deny. Okay, modus tollens is a deductive argument form and it has a rule of inferences lah. Modus tollens can take a form of if P then Q, not Q lah. If P and Q, not Q lah. For example tadi, yang kita dah tengok, okay, Facebook lah. Facebook, if you cannot, if you have password as a P, and then you can log on to the Facebook lah. Okay, you cannot log in to the Facebook, negate Q. Okay, therefore, you do not have a password lah for the P. Okay, negate P. Okay, okay lah. This one is modus tollens lah. Again, for the modus tollens is the deductive, deductive argument. For the modus ponens is the also is the deductive argument form and the rule of inferences. Okay. But this one for the modus ponens is you affirming the antecedents. Okay. For the modus tollens, you affirming the consequences. Consequent. Okay. Consequent for the modus ponens. And for the modus tollens, and this one consequence. Okay. The consequent. Okay. Okay. The other one you affirming for the modus ponens, you're affirming the antecedent. Okay. The value before and the value after. And then number four, number four, number five, and then number six, number five, number six is hypothetical syllogism. Okay, we have a hypothetical syllogism. If P implies Q, okay, and then Q implies R are two premises. We have two premises or two hypotheses. Uh, we can use hypothetical syllogism to derive P implies R. For example, here, if it's rain, I shall not go to the school. P implies Q, and then Q implies R. If I don't go to school, I won't need to do the homework. Q implies R. Therefore, if it is rain, okay, if it is rain, P implies R. R is I won't need to do the homework. I not need to do the homework. If P implies R. Again, it is a hypothetical syllogism. Okay. Kamu tulis tak ni? Nonila Sari, kamu tulis tak ni? Ke kamu tengok je ni? Nonila Sari, kamu tulis ke kamu tengok je saya bercakap ni? Okay, please write some notes because this one is important for your final exam. Okay, in a classic logic, the hypothetical syllogism is a valid argument form. A syllogism with a conditional statement for one of both as it premises. For example, in English, if I do not wake up, then I cannot go to work. Lah. If I cannot go to work, then I will not get paid. Okay. For example, you have P implies Q and Q implies R. Okay, we can say that we eliminate the uh, same consequences. Okay, as a Q. Okay, we eliminate then P implies R. For example, if I do not wake up, okay, as a P, then I cannot go to work. Okay, okay. If I cannot go to work, okay, then I will not get paid. Okay, this one is hypothetical syllogism. This one is conditional statement. Basically, this one is conditional statement that contain one or two premises. Okay, and then we can have disjunctive syllogism. We have if negate P and P and or Q are two premises, we can use disjunctive syllogism. Okay, for example, negate P. The ice cream is not a vanilla flavor. Okay, and then P or Q. The ice cream is either vanilla flavor or chocolate flavor. And then we can see that therefore the ice cream is chocolate flavor lah. Okay, for example we have again P or Q lah. The ice cream is either vanilla flavor or chocolate flavor lah. Okay, and then we have P, the ice cream is not a vanilla flavor, negate P, and then therefore for the Q, the ice cream is chocolate flavor lah, because it is a disjunctive or lah. Okay, disjunctive syllogism, also known as modus talendo tollens, is a rule of inferences of professional logic that state if P or Q is true and is not P is true, then Q is true lah. Okay, this one is disjunctive. Okay, number six, number seven. Okay, and then we have a resolution. Resolution. Okay, as you can see here, we have P or Q, and we have negate P or Q, that implies Q or R. Okay, this one is addition. Addition. Okay, and then you can see that therefore Q or R. Wait, I search for the example. Okay, in mathematical discrete it is a rule of inferences leading to a refutation complete theorem that a proving technique for sentence in professional logic and first order logic. Okay, and then the clause produced by resolution is called sometimes called as a resolvent. Resolvent. Okay, sometimes you can see the clause. The clause resolvent. Okay. Okay. Later we see this one in detail. In detail. Okay. Next is. Okay. This one is example of simplification. Okay, this one more on example. P is below freezing. Q it is raining now. It is below freezing and it's raining now. Therefore, okay, here this one I have explained it. Therefore, it is below freezing. P. Okay, and then we have a modus ponens that mode that affirm the affirm the antecedent. For example, here we have if hypothesis P is true, okay, and the hypothesis P implies Q is true, and then I can conclude Q lah. Therefore, I can conclude Q lah here. Okay, this one is model exponent. Okay. For example, Pn is greater than 3, Q and power of 2 is greater than 9. Assuming that P is true and P implies Q is true, then therefore, if is n is greater than 3, it follows that n power of 2 is greater than 9. This one is model exponent example. Okay, okay, later we go by the exercise. Okay, we see the example by the exercise.